Hello and welcome to Math Method. Today we're gonna write a Pong game. I love programming JavaScript. It's so fun, you just put the project out there, people can access it, and it hopefully works for most people. Except when you have old browsers, of course, and that is not fun.
You're watching the most exciting game you will ever see on your TV set.
That's correct. Today we're gonna make the most exciting game that you've ever seen. Pong is one of the first video game consoles that became popular. There were a lot of different names and derivatives of the Pong game, but all of them contained a ball, 2 paddles and a score count. Today we're gonna implement the simplest version, which is basically a ping pong simulator. Here we have an index.html. It contains a canvas and a reference to our script, pong.js. The canvas has the ID Pong here, and it has a width of 600 by 400. I've also set up a browser, which has loaded our index.html here, and then a reference of the game. The first thing we want to do is access the canvas. Const canvas equals document.getElement by ID, and ID was Pong. Then we want to get access to the canvas context. The const context equals canvas.getContext. And we want the 2D context. We want to draw the canvas completely black. So we say context.fillStyle equals 000, which is black. And then context.drawRect. I want to draw it from upper left corner and then the full width and height. Canvas.width and canvas.height. So if we go out to the browser here and select our dev, we should have a black square. No, because this is named fillRect. There we go, now it should work. No, perfect. I love this. How can there be a bug already? It's quite fantastic. Okay, that's all for today. Here we go. It's the width there. Okay, there we go, fantastic. Okay, so now we want to draw a ball. We copy this, and the ball is white, so we set the fill style to white, and the ball is 10 by 10 pixels. 10. So now we should have a white square in the upper left corner. There it is. Well, this is obviously not super useful, it's pretty hard coded. So we're gonna set up a vector class to hold an X position and a Y position. Class vec constructor, and it takes an X that defaults to 0, a Y that defaults to 0. And then we add those as properties. This.y equals Y. And now we have a vector that we can reuse. We're also going to paint rectangles a lot. So I'm going to generalize a data structure for rectangles. We call it class rect, not fillRect, boom. And it has a constructor, also with an X and a Y, but in this case it's gonna be width and height. So we actually call this width and height here. And the rectangle needs a position, this.pos equals new vec, and it needs to save its size. So this.size equals new vec with width and height. Then when we have this, we want to use the rect to create a ball. Class ball extends rect, and the constructor here, constructor, we do nothing, but in the constructor we call the super with 10 by 10, which should set up the size on the rect. And we also want to add a velocity here, this.vel equals new vec. There we go. So now we can create a new ball here, const ball equals new ball. And for fun, we can console.log it and see what it looks like. So we see we have a ball that inherits from the rectangle. It has a position that's default to 0, 0. We have a size that should be 10, 10. And we have a velocity that's also 0, 0. Now we can use this ball as a basis for painting the ball instead. Say ball.position.x, ball.position.y, and ball.size.x, and ball.size.y. And now to prove this concept, we can change the ball position here. Ball.position.x equals, let's say 100, and ball.position.y equals 50. There we go, so now the ball moved. So the next step is we want to animate the ball. So first we create an update function update, and it should take a delta time. And in the update function, we will update the ball's position and say ball.position.x plus equals ball.velocity.x times delta time. That means that the movement of the ball is relative to the time difference of the update methods. And the same goes for the y value here. There we go. In the end of the update thing, we're gonna redraw everything. So we move the context in here. There we go. And now we're gonna use requestAnimationFrame to update the ball's position. requestAnimationFrame is a function that takes a callback and then calls the callback for the next time the browser is ready to draw. In the callback, you'll get the elapsed time since the page was loaded. So we're gonna have to calculate how much time has elapsed since the last requestAnimationFrame. So let's start with a variable called last time. And then we want to actually call back here. So we say function call back, and we're gonna get milliseconds from requestAnimationFrame. So in here, we need to check if we have a last time. If we do, we can calculate the diff. So we can run update with the diff and say millis minus last time. I also want to convert this to whole seconds because I find that easier to work with. So we're gonna divide it by 1000. And in the end here, we want to set last time to the millis of this, because requestAnimationFrame only calls the callback once. We want to attach the callback itself to requestAnimationFrame again. So if we add a velocity to the ball now, it should fly over the screen. Let's give it a velocity of 100. And one for the y-axis as well. Then at the end, we need to call the callback at least once first. Just call callback like that. There we go, we have a ball moving over the screen. Whoop, and there it disappeared forever. Let's mitigate that by adding some bouncing. So in the update method, we want to detect if the ball touches any corners of the screen. We can do this by saying if ball.x is less than 0, that means it passed the left end of the canvas, or ball.x is more than canvas.width, that means that we have passed any of the horizontal ends. If we have passed any of them, we want to invert the velocity. So we say ball.velocity.x equals minus ball.velocity.x. And we'll do the same for the y positions here. Y, and then we want to compare that to the canvas height instead of the width. So now hopefully we have a ball bouncing here. Perfect. Because something hilarious has happened. Time to debug. Brrrt. So if ball.x... Oh, I'm so stupid. Yeah, we need the position here, I think. Pause. Pause. And we do the same for the y here. Let's see if we have better luck. There we go, that looks much better. Before this becomes too messy, I want to add some scaffolding here. The first thing I want to add is some special getters on the rect. And we want one to get the left side of the ball, so we say get left. And it's going to return this.position.x minus this.size.x divided by 2. This means that we can easily get the left end of the rectangle. We also want this for right. We'll copy this here. And for right, we're gonna do the same thing, but we're gonna add instead. And it will be very convenient to get this for top and left too. No, top and bottom. That should do it. So this will allow us to do a couple of things. First of all, we can work with the center of the rectangles, and we can also get the left and right side of a rectangle without having to worry about addition and subtraction here. So we actually want to bounce the ball when its left end hits something. So here we say if ball's left is less than 0, or ball right is more than canvas.width, that's when we bounce. And the same we can do for top. Ball.top less than 0, or ball.bottom is more than canvas.height. So this should be a little bit more exact. Let's see if this works. Here it goes, and it should bounce when the bottom hits the bottom. It looks okay. Right touches right, top touches top, and when left touches the left side. The next thing I want to do is wrap this program in a class. So we'll start here with making the Pong class. Class Pong. Pong. Constructor, it takes the canvas. Then we say that this.canvas equals canvas. This.context equals, and we copy from down here. And we want an update method. We can copy the one we have outside here. And we want to update the reference to context. There we go. The same is going to be done with canvas. Let's see if we can clean this up a little bit. We're also going to initialize the ball inside the class. So this dot ball equals new ball. Ball dot this. Here we go. That means we also will have to use this dot ball here. Ball. It's a little bit of padding. And we also want to bake in this thing in the constructor. So now we need to initialize our full game. So we say const Pong equals new Pong canvas. So because we need to say this.update in here, we can't use a classic JavaScript function. So we're gonna need to make this function an arrow function. So we can say const call back, and it takes the millis still, but instead we say arrow function style. So now we will be able to write this here, because arrow function doesn't have a this context. There we go. Now we have a game wrapped in a class, which is a little bit nicer to work with. We can also unify the fill rectangles to a draw rectangle method. So let's add this now. Say draw rect, and we take a rect as an input. And we can copy this part, or actually we rather copy this. There we go, context field style, and instead of saying this.ball, we'll say rect of all these things. Then of course we need to actually tell it to draw the ball here. This.draw rect, this.ball. We should make it a little bit nicer and move out the draw things from the update method. So let's do that now. Draw. and call draw. There we go, much nicer. So now we're going to set up the players. So first we create a player class player extends rect, because we're going to draw them as rectangles. Constructor will take no arguments, but we're going to call its superclass with 20 in width and 100 in height. And instead of a velocity, player's going to need a score. So score equals 0. There we go. Then in constructor, we set up a players array that contains all the players. Players equals array, and then 2 instances of players. New player, new player. We also need to draw these players, so in the draw function we can say this.players.forEach player this.draw rect, because the player is also rect, we can do this. So if we move back out now, we should have something more drawn. Yeah, we have a lump up here, which are 2 players drawn over each other. So let's draw them in the right place. This.players 0, that's player 1, dot position dot x should be 40. So it put player 1 40 pixels from the left. Player 2 with index 1 should be 40 pixels from the right. So we can say this dot canvas dot width minus 40. And then lastly, we're going to put them in the middle. So this dot players dot for each player, and say player dot pus dot y equals this dot canvas dot height divided by 2. There we go. Now they're kind of nice, but we have one problem here. See, we're not drawing in them from the correct top. So let's mitigate this problem. I suspect it might be here. Yes, we should draw rect.left and rect.top instead. So now everything's drawn from the center out. There we go. And this is also true for the ball, so now the ball should bounce exactly. So now it's time to make our players move. Player 2 will be driven by the computer, and for now it's just gonna be using a very unfair AI. It's just gonna follow the ball's Y position. So in the update method we can simply say this.players index 1 dot position dot y equals this dot ball dot position dot y. This should make player 2 follow the ball. Looks right. Player 1 will be controlled by the mouse. So let's make a handler down here for that. Here we should be able to say canvas.add event listener mouse move, and we will get an event from this. And here we will say pong.players with index 0 dot position dot y equals event dot offset y. Let's see if this works. There we go, it follows the mouse. So now we almost have kind of a working Pong game, but as you see we have no collision detection. So the ball doesn't care about the paddles. So let's add a small collision method up here. We say collide, and it takes a player and it takes a ball. So now we're going to be very happy that we added the left and right and top and bottom getters, because we can simplify this a lot. So if player.left is less than ball.right and player.right is more than ball.left and player.top is less than ball.bottom and player.bottom is more than ball.top. This should mean that they are colliding, the player colliding with the ball. And when that is the case, we want to negate the ball velocity again on the x-axis. So ball.velocity.x equals ball.velocity.x and the negated version. Then in the update method, we need to test the collision. So we say this.players.for each player and say this.collide player this.ball. Let's see if it works. So now hopefully player 2 should bounce its ball back to us. Good, and player 1 should do the same. Nice. Alright, now we need to add some kind of score count here. And in order to do that, we can use this if statement here. When it hits the left or the right wall, we can just check the velocity and decide what player should get the score. So if the ball is traveling to the left, we give player 2 a score, and if it's traveling to the right, we get the player 1 score. So let's do this. So basically we can say let player ID and then if ball.velocity.x is less than 0, then player ID equals 1. So the second player should get the score. Else player ID equals 0. So that should be the right thing. So now make sure that we log out the right player ID here. When I miss the ball here, it should print. It should print a crash. Perfect. Okay, here. Let's put this in this context. Alright, let's see now. It should print 1 here because boom, so there's a bunch of 1s. Perfect. Go back here. But I want to show a little bit of a trick here. We can simplify this to a one-liner because this statement here will return true or false, and we can easily convert that to 1 or 0 by casting it to an integer. And the way to do that in JavaScript in this case is to just bitter it with this sign. So now this part here will say true or false, and this will say convert it to an integer. We say const here player ID, remove all this, and we should get a 1 printed in the console again. There we go. Good. Now of course you could see that it printed it a lot. You see we just keep on printing here because the ball is traveling beyond the left border. So I guess once we detect that the ball has left, we need to reset it somehow. But first we should add the score count to the right player. We can say this.players player ID .score++. And then we also say this.reset. And what does the reset method do? Let's write that now. Reset. I think it should set the ball here and the position. Let's copy this down to reset method. Boom. And then we run the reset method in the constructor initially. So now the ball should just jump up from the beginning origin once it leaves the left screen. There it goes, and we miss it intentionally, and we get a repeating loop here. Let's try it in another case here. Okay, works nicely. Didn't really do the right thing, so we're gonna first of all put the ball in the middle. So we say this.canvas.width divided by 2. This puts the ball in the middle. And we want that horizontally too. So we say height, and I think I spelled it wrong. I mean, correct. And the velocity should probably be 0 because we want to initialize the velocity with a click. So now we probably just get a static ball in the middle. Okay, very bad. So let's add a start method. Where should we put it? Yeah, here. Start. What does it do? So it checks the ball speed, because we can only start the ball if it is not in motion. So let's say if this.ball.vel.x equals 0 and this.ball.vel.y equals 0. So the ball, we know, if the ball doesn't move, we can give it speed. Just gonna copy this from here. And we set this simply to what we had before, 300 and 300. Then we want to run this start method on click. So new event listener, start, no, click. Click on the canvas, and this just runs pong.start. So yeah, boom, there it goes. It should reset to the middle, it does. And it works. And just for fun, check the player score. Pong.players. And you can see player 1 should have 0, right? 0, and player 2 should have 2. Perfect, everything seems to work. So one thing that we notice now is that the ball always travels the same direction when it starts, which is kind of boring. So let's add some randomness here. The x speed we can set times math.random. And now we're gonna set, is it starting to the right or the left? So we're gonna just randomize this 50-50. So we can say .5 if it's 1 or -1. So this is ternary operation, which says that if what is given back by math.random is more than 0.5, then we multiply the x value with 1, which has no difference. But if it is less than 5, we multiply it with -1, so we negate it. And we want to do something similar to the y velocity. So we say math.random times 2 minus 1. So this should just tweak the 300 value a little bit, so that the speed up and down differs a little bit. Let's try this and see if it's a little bit more dynamic. So there it went. Good. Okay. Have 2 to the left. We went to the right. Went up. And I think what we can see here is that the ball speed is inconsistent. Because now we tweak both the horizontal and vertical velocity, which when they add up, you can get a much more, like the factor of the velocity is much higher. And we can normalize that pretty easily with a simple function. So we're gonna add that to our vector. Scroll up to the vector. Here we go. And we're gonna add 2 getters and setters. The first one is the getter that will get us the length of the vector. And the length is just a combination of just both x and y. Is the hypothesis, how the fuck do I say this? Is the hypotenuse of a triangle, and len we call it. And when we read the property len, we get return math.square root this.x times this.x plus this.y times this.y. If you have done your geometry in school, you will see that this is how you calculate the hypotenuse of a triangle. We can do something similar to set this. So we're gonna set len, and we take the value, which is the length of a vector. First we want the factor, fact, equals value divided by this.len. So now we have a factor between the value we want to set and the value we currently have. And now we can simply multiply each of the vectors with this. This.x times equals fact. And we do the same for y. And we can apply this down in a reset method. Here. No, start method. So after we set this, we have kind of 2 speeds, but we can normalize that to a unified speed or length that the ball travels on every iteration. So we can simply say that the ball initial velocity's length is something. And I'm gonna go by 200. This.ball.vel.len equals 200. And what we should see now is that the ball has a consistent speed from the get-go. Let's see. Here it goes. A little bit slow, but I think it's okay for a Pong game. So let's lose now and see. Make sure it's correct. Boink. Or actually we can do it a little bit more scientific. We're gonna read the ball speed in the console. no. Pong.ball.velocity.length. 0 now. Click. 200. 200. Okay, can we get a discrepancy now, please? Too little discrepancies here. Oh, this one. Oh, this one goes. Oh, 200, perfect. The ball speed is consistent. Now we want to up the action a little bit. So every time we hit the ball with the paddle, we want to increase its speed. So let's find the collision method. And here, when we negate the velocity x, we can also increase the length. So we can simply say ball.velocity.length, and we can multiply it with, for example, 1.05. So this should increase the ball speed with 5% every time you hit it with a paddle. Let's see if this works. It's very tiny, but we should see it in a couple of rounds. Let's see now if it has increased. The ball length should be higher. Yeah, it's increased with 25%. Okay, now it's easy to see. So I'm gonna lose now. I think we proved the concept. Okay, cool. Another thing we can do to make it a little bit more interesting is to jiggle the ball direction a little bit. So here we can not only negate x, but we can tweak the vertical velocity. So first we're gonna save the ball length, because we're gonna alter that once we alter the y. So we say const len equals ball.vel.len, and then we negate x, correct? And then ball.velocity.y. We're gonna add some randomness to this. Yes, plus equals 300 times math.random minus 0.5. What does this mean? Wait. 300 times it. Yeah, I guess it's okay. Like we just add with 300, then we add some jitter to it, math for random. I think it's gonna work. But now this will need to be len times 1.05. So what we have here is we save the current ball velocity, negate the vertical velocity, we fudge the horizontal velocity, and then we replace the length but increased with 5%. Every time you hit the paddle, there should be a little bit different angle on it. Let's see if it works. Oh, definitely works. That was massive. Let's lose. Bang. Now we seem to have most important traits of a Pong game in order, but we're lacking the score count. And to be honest, this might be a little bit tricky to follow, but I'll try to explain. I must admit that I'm cheating a little bit because I have notes besides me. But anyway, first we're gonna set up the graphics for the numbers. The Pong numbers I will show you here in the example, they're like pretty simple. 3 pixels wide and 5 pixels tall. So they just went 1, 2, 3. So basically on, off, on, off. No, on, off, on, off, on, off, on. And the one is just off, on, off. Yeah, you get it. Let's get some more numbers here. 2 is just on, off, on, off, on. Let's see the 3. Yeah, you get the deal. So all these numbers is basically just 15, whatever. So just as an example, we're gonna write out the 0. So it's 1, 1, 1. Then, whoops, we have 1, 0, 1, 1, 0, 1, 1, 0, 1, and then 1, 1, 1. You should see that there's a pattern here that looks like a 0. It's just not as wide. And we're going to do that for all numbers. And we don't need the line breaks because we know that all are 3 wide, so we can just do some tricks later. So let's combine these. Trut. 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 We're gonna put all these numbers in an array, and conveniently enough, an array is 0 based. So the first item here is the 0. So that's kind of convenient for later. And now we have the 1. It's gonna say 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0. And the 2 is 1, 1, 1, no, no, 1, 1, 1, 1, 1, no, no, 1, 1, 1. And number 3, okay, I'm gonna fast forward this. There we go, there's our matrix. This chars equals boink. Put this in an array. There we go, we have chars. And in order to convert these to graphics, we're actually gonna cache a couple of canvases in the beginning of the game. So we're gonna map over this array and say map string. I'm gonna create a new canvas there. Const canvas equals document dot create element. So now we create a new HTML element that we can paint on. Canvas. And we're gonna say how big is a pixel? A pixel is 10 by 10. So we're just gonna say up here, this char pixel equals 10. And then we need to know the canvas height is gonna be 3 pixels by 5 pixels. So canvas dot height equals this dot char pixel times 5, and the width times 3. Did I spell that wrong or right? Yes, looks okay, but so I thought last time. Now we want the context again, just as we got earlier. Const context equals canvas.getContext, the 2D context, and we want to fill this white. Context.fill style equals, and this is the hex code for white. And now we need to, we're gonna iterate over each char here and paint the canvas initially. So we're gonna say string, and this string is the one we have up here, dot split. And so now we can iterate over this string with for each. And fill is gonna be a 1 or a 0 here. And the index. And so if we have a 1, we want to fill, otherwise we don't want to do anything, because that's gonna leave the canvas transparent. So if fill equals 1, then we paint a pixel here, 10 by 10. Context.fill rect, and I, which is the index of the character, modulus 3 times this dot char pixel. So what is this? This does is, I don't know how to explain this. It calculates how much is over when you fit 3 in I. There's more of modulus on the internet you have to look up. And then I out of 3. So now we split I with 3. And we floor this. So this number can also floor numbers. It's magic, I understand. This, let's get this on another line. And this too. Boink. Dot char pixel. So now we know we have the top left corner or we want to paint. And of course we want to paint it of a size of a char pixel. This char pixel and this char pixel. This should leave us with an array of canvases that we can use to paint later. In order to prove this, we need a draw method. Oh, we need one more thing. Return the canvas. So to iterate, we go through all these strings And for every string, we create a new canvas. And on each canvas, we draw for every one a white square. So it should fill the canvas according to the matrix of numbers that we defined earlier. Okay, so now how do we draw this? Let's add a draw score method here. Draw score. And this is also going to be a little bit convoluted, but let's just do this. The alignment needs to be centered. So this.canvas.width divided by 3. That means that we have the whole canvas split into 3 spots. So we divide this whole thing with 3 and we get approximately here and here as length. And now we need to calculate a character width. So we say const char width, char W, and it's going to be this.char pixel times 4, because one character is 3 pixel units wide, and then we leave 1 extra pixel unit as space. And with this we can go over the players. This.players.for each, and we say player and index of the player here. And now we need to convert the score into characters. So we say const chars equals player dot score dot toString. So toString on a number gives you back the string as a number. Very strange. And then we want this as an array, so we can say split immediately here. Now we need to calculate the offset. And to be honest, this is the trickiest part of the whole Pong game, which is a bit hilarious. So now we say const offset, and this is offset from, I don't know, I guess it's the left. That would make sense. So we can say align times index plus 1, then minus char width times chars.length, and this is of course how many integers there is in the number, and we can half that because we want the center of it. Then times this.char pixel. Oh my god, we need a new line. Where should we put it? I guess we separate everything that isn't enclosed in parentheses. Times this char pixel and split by 2. Something like that. I think that's fair. So now we have the offset that we're going to use, and now we can say chars.for each and char and position. So this would be just position 1 and position 2 depending on. So if you have 12, the 1 will be position 0 and the 2 will be position 2. And we draw this dot context because we draw on the Pong context. And now we say draw image, and we can actually apply the index of the canvas that we prepared earlier. And we have all those images, prepared canvases, in the chars property. So this.chars, chars, and the index is char typed to integer. So this magic pipe plus 0, it can do so much in JavaScript. It floors numbers, it converts them to integers. It's quite convenient. So this says that since this char is a string, because we made a toString here, splitted it and iterate over them, we cast it back to an integer here. I'm not sure this is the absolute best way to do it, but we're gonna do it this way today. And we say offset that we got earlier plus position, which is from here. So like the 1 for position 0 for 12, and it's 1 for the other thing. So we just have the offset plus position times char width, and we want to paint it with 20. What the fuck does that mean? I guess I don't know if it doesn't need to be there. Let's try this and then let's close everything. I have no idea. Let's see what goes. Whoops, unexpected token. 164. What did we miss? Oh. Shoop. Okay, we have no score because we need to call the paint, the draw score function, of course. And we can do that in the draw function. This.draw score here. Well, if this doesn't blow up, I'm gonna be laughing. It blew up. Okay, draw image, three arguments. I don't know what the last argument is. Canvas, draw image. Let's check this. This is gonna be surprising, hopefully. It is... Oh! First image. Okay. So my notes were not good enough. Let me explain this a little bit more clearly, if I can. In the draw score method, here is what we draw. We draw it at this X position and 20 pixels from the top. Let's try again. Holy smokes, where's my canvas? Oh, here it is. Kablam. We have numbers. It's a little bit off. Let's see if we can fix that. I think we need a plus sign here. There we go. Look, it's a Pong game. Fantastical. So let's try the score counter here and say Pong.players.0. I'm gonna give myself some score here and then boom. Oh yeah, take that, impossible AI. I guess I proved my point here that the hacker always wins. And now for the last part, we just gotta pump this full screen. We need to do two things. We need to adjust the CSS, and then probably we need to do something to make the mouse correct again, because right now everything is pixel perfect here, like we haven't resized anything. But let's take that problem later. Back to the editor, and we go into our index.html. Up in the head, we make a style tag. And in this we say body, and we're gonna display it as flex. Display flex, and we want to align the items in the center. Align items center. We also gonna change the background color a little bit. Background, make it a deep gray, and no margin, 0 margin. And as for the canvas should be, I think it needs a little bit of a border, solid 1 pixel white, so we know when the ball will hit the wall. So we only need the border and the top of the bottom, so we're gonna turn off the border to the left and right there. None, and border right, none. Then image rendering, we can set it to pixelated. I think this might just be a Chrome thing, but let's do this. And then width 100%. Let's see what we got now. Holy smokes, nothing. Woohoo! Probably missing something. Oh, ending the style tag. There we go, full screen Pong. I think we only need one more thing, and it is to make the mouse accurate. And also I think maybe today we want to adjust for height instead. So we're gonna say here, height is 100. Okay, that's a little bit better because I'm capturing this in super wide screen. I think we should center the whole thing too. So we could probably just add margin. How would I do that? Align item center here, that's top and bottom. Let's look up the flexbox. Flexbox. This is a great resource. And want to align it center. Align self, align items, that is center, but how does it apply? Is it align content? Let's see what happens. I don't understand exactly align content, align items. It sounds like the same to me. Nope, wasn't that. Oh, fuck you. Let's just do this. 0 out to. old school. There we go. So now let's fix the mouse. Back to our script. Go down to the mouse move event. And we need to mitigate for the upscale canvas here. So we're gonna say here const scale equals event.offset y. And we split that or divide that with event.target.get bounding client rect dot height. I mean, so now we have a scale factor here, and we should only be able to we need to multiply it with the canvas height, I think. Canvas.height times scale. There we go. Now we follow the mouse pointer, nice and dandy. It bounces on the pedals. It counts score. It resets, and it's unbeatable, just like the regular Pong. So that's how you make a Pong game. Okay, so we're gaming around here, having a lot of fun. Doing that, catch that ball, opponents catching it too, doing what I can to save the day. And, oh no, okay. Okay, so I lost this one, but ladies and gentlemen, that was the greatest game in the world.